Then from that point, measure 5 centimeters. In an homogeneous soil deposit, a cut has been dug to a depth of 10 meters, featuring side slopes with a ratio of 1 vertical, 2 horizontal. Laboratory testing has disclosed the soil characteristics as follows. Cohesion, which is C, is 40 kilonewtons per meter squared. The angle of internal friction, which is phi, is 10 degrees, and the unit weight is 18 kilonewtons per meter cube. So the question is, compute the factor of safety for the slope considering the slip surface illustrated in the figure below. That's figure 1. So you should see the figure in the question. So from the figure we can see this depth or this height depending on your reference point, and we can see the side slopes. So we've gotten here. So please take note of the slope. The ratio is 1 vertical to 2 horizontal. There are 2 ways to it, but one is faster. You can actually do the 2 just for the mark. So since it's 1:2, that means whatever you have vertically, you have times 2 of it horizontally. So if we measure here 10 meters, but on your paper it's 5, right? That means you are going to measure 20 here. But in reality, you are going to measure 10.
10 boxes.
Don't use 10 boxes, please. Measure 10 centimeters. So from here, measure 10 centimeters.
No. You don't. On that section, we measure 5 boxes to represent 10
meters. Now we are measuring 10 to represent 20 meters.
To represent
That's what I just explained here. Because of the slope. So it's just like this one equals to 10 meters. Then 2 equals to x. You can just cross multiply, then you get plus 20. So that is why we're measuring 20. And if you like, you can actually use the angle here to find the length. It will still give you the same thing. You are measuring 10 cm. Are we there? Yes. So for this one, you can make use of a faint line. It's not compulsory stick. So just a faint line. So let's say our 20 is here. Have you gotten your 10 centimeters? So after that, all you just have to do is to join this point to this point. That's your slope. So you just join this point to this point.
You can use broom.
We are drawing the slope. Okay. We are trying to reproduce the diagram in the question.
Which one? Sorry.
So are we there? Yes. So after drawing the slope, please don't forget to label, although you can actually label later. So we can call this 1.A, point B, like that. So after drawing the slope, from the question, we've been told that the distance from the top of the slope to the horizontal side here is 2.5 meters. 2.5 meters. So for us to measure at 2.5, what are we going to do? That's what? 1.25. So with your ruler, you measure 1.25. So okay. After you join this point to this point, according to the question, we're given the distance from here to here, which is 2.5 meters. But because of our scale, we are not going to measure 2.5 directly. We are going to measure 1.25. That's 2.5 divided by 2. So just mark it and join. It's in the diagram. The point of the rotation so that we can get our angle of rotation. So the radius given in the question is 19.8 meters. So with that scale, it's going to be 9.9 centimeters. Just divide by 2. So with your compass now, I believe everyone has fixed the pencil in their compass.
Instead of using the black part, you use this part. I use it to control it to work.
So with your compass, measure this 9.9. Let's call this one. So stand on point A, make an arc. Yes, on point A, just draw with your compass, just draw an arc. Point A. Can we continue?
Yes.
Okay. You also did the same for point B.
You don't make an arc.
You stand on point A, extend your compass, just make an arc. Stand on point B with the same 9.9.
Same radius.
Make another arc. They will intersect at a point.
Is it at point where you can make that
This is
arc?
point A.
Only at point A.
It's on point C.
I should go back the other time. I think that was the reason why I forgot that. Yes, point C.
That's where
So we have point A, we have point B, now we have point C. And don't forget, point C is 2.5 meters from point B, but on your paper is 1.25 centimeters. So here, this, then here, this. So this point now, you can call it our point O. Please don't shake your compass yet. Make sure it's still 9.9. So you now come back to point O. You now make an arc. So this is how you know whether it has been adjusted or not. By the time you make an arc, it will start from A and to end on C. Yeah, stand on point O, then just draw an arc from A to C.
You see something?
So it must touch these 2 points, it must intersect at this point. You have something like this. Yeah. No, it must touch C. You know, you do this from C. So by the time you make that arc, it's your ruler. Join O and C together. Join A and O together.
Elijah, calm down. This is your voice.
Explain just.
How we got C?
No. 1.5.
We know whether this is where we already have different things, yeah. So I want you to measure your theta. What do you have? Can you measure the angle here?
The mayor, angry.
Theta. What's your theta? I believe you should have a lot. Some people will have 75, some people will have 72, some people have 78, and some will have 77. So just measure your own and tell me what you have. Will be the center of the center of protractor will be on it. Please, can I have a protractor so I can explain? So if we are using this line, then this center here, we have to be on point 0. Then the other part must align with your own name. Then you have to take the reading. And if you are using this one, you just do the same thing. So 74. We are at the point where we slice exactly where we slice. So this point is very important. So according to the rule, it says you can have minimum of 6, maximum of 12. That means it can be greater than or equal to 6, but less than or equal to 12, right? So to make your work faster, we don't have time, we have 30 minutes, just 30 minutes. I think we should just go with that 6. Yes. Because it will reduce your calculations, the number of lines you have to calculate for. Yeah. So, and to go with 6, we have to look at it from here to here, which is 20 meters, that's 10 centimeters, right? Then from here to here is 1.2. So everything all together is 11.25. So looking at it now, we can actually divide it into 2 centimeters. Then the last one will not be up to 2 centimeters, right? So on this line now, on this horizontal line, you measure your 2 centimeters. On this line, on your ruler, but in your mind, you already know that 2 centimeters you are measuring is what? That's 4 meters. We are measuring 2 centimeters, but in real life, it's 4 meters. So, how can I divide this one to make it 6? Okay. So, who has done the division? Right. So, faint line. So the line should be faint, but it shouldn't be too thick. So you just draw it up.
To which point?
Just make sure it slices.
Is it to that or what to that line?
It's to this line, but since it's faint line, you can draw it as long as you want. For clarity's sake, let me just. So just make sure it touches the slope and the curve. It's very compulsory. Although we might still have to extend it later. After you've measured, let's say.
Sorry, your vertical line is coming from B down or
The vertical line is from
OC or
we are still going to need a line that is longer. So you can, since it's faint line, you can extend it. But I don't think we are doing anything with this one. They are faint lines, so you can just make it as long as possible. But just make sure it intersects this curve and this slope. So if you like, you can stop at this point for this slice though. And if you like, you can extend it. So it doesn't change anything. It's the middle one that is very important. So, like I was saying, don't trust your graph. Don't say because it's 2 by 2 square and you now say if you calculate like 8 of it and now say it's 16, it won't be 16, it will be less than that. So it's better you use your ruler. It's what your ruler gives you that you are going to put down. Don't trust those squares, they are deceiving. So after doing the division, so we have to get the center. No, we measure 2 centimeters here, right? Now we have to measure 1 centimeter. But before you do that, please take note. This last one is not up to 2 centimeters, it's only 1.125. 1.25, sorry. So all we just have to do basically is to find the center. The center of this place, the center of this place, the center of this one, for this, and for the last one.
Center.
Yes. So for this one now, it's going to be, the center is going to be at 1 centimeter. That one is correct. For this one is also going to be 1 centimeter. So you notice that I'm extending this line because we are going to use this line to get our alpha later. The last one is going to be half of 1.25. So that's 0.65 or something. Okay, 625. So it's just the center. So after doing this, you can now put number. You can number this as 1, 2, 3, 4, 5, and 6. The next step is to join this point to the point where your center line intersects the curve, not where the center line intersects this line A or something, where it intersects the curve. So for this one, it's going to be, please don't mind my line. Something like this. So from this one to this one, you are going to draw. Yeah, from this to the center. So it must. So what you just have to do is to place your ruler on this point, and on the point where it intersects the curve. I hope you are seeing the points I shaded, I dotted. So that's where you are going to draw your lines through. So for this one now, it's going to be through this. From 0 to here to here. So because me, I'm only trying to draw to scale. I'm just trying. It's not really correct. That's the reason why I don't have any negative. But when you do yours, you are going to have at least 2 negative values. So once we start measuring, I will go back to that. So let's do the each point of that
Intersection.
is up. So don't make your lines too thick. Oh. Make it visible enough for you to know what you've done and for the lecturer to see, but not that it will disturb other things. Then we have our table. Slices. And we have slice 1, 2, 3, 4, 5, and 6. Right? Yeah, right?
Yes.
Let's fall down one here. So please take notes. This area aspect is very important. So for the area now, all what we want to do is to find the area of each of the slices. So we have slice 1, slice 2, 3, 4, 5, and 6. So for the first one, you pick your ruler, you measure the distance from here to here. That means the distance from where that dotted line intersects the curve to the top, to where the line intersects the slope.
That's the height.
You see these 2 dots? So that's what we want to measure. Where the center line intersects both the slope and the curve.
The height.
But that's not what we are recording. We are recording the area down. We want to record exactly. We just measure the length. We need to multiply it by the breadth. Yeah, the breadth is meant to be 2, 2.
Four.
It's going to be 4.
Because of the size of the slide, 6. The breadth of the last one, the start what we have there.
Yeah, we measure what we have there. So we are not using. We didn't use 2. So it's what you have there that we are going to use.
So the remaining 5 will be 2.
Please look up before you continue. Have you measured the distance from here to here? From this point to this point. Okay, you have 0.7. Times 2. So see, please, I want you to take note of something. There's a very easy way to it. Okay, with the way we did our own, I have 0.5.
0.7.
Anything you have. Anything you have. With the way we did our graph, after you measured anything you have there, multiply by 8. That's the answer. But this is the trick behind it. Let's call the distance from here to here. Let's call it x. But in reality, it's 2x, right? Because it's times 2. That's our length. L equals to 2x. Yes. Then the breadth is what? Let's say the breadth is 4, right? No, the breadth is not 4. The breadth is 2. But let's call it y. That's 2y. So length times breadth is going to be 2 times 2, which is 4xy, right? 4xy. But we already know that our y is equal to 2. We already know now that our y is equal to 2. So that's why the area is now 8x. That's 8 multiplied by whatever we have here. That's just a simple trick to it.
For this particular question.
For this question. For this question, wait, for this question, for this scale.
You cannot work for that question.
For this question, for this scale. Let's treat it the way it is. So we'll compare the time.
Whatever we mentioned there, not like
How can you arrive at this?
No, that's what I don't expect, but we'll do it later. Let's do it the way it is. Please, what do you measure from here to here?
0.7.
Okay, so let's take 0.7 as an example. But times 2 because of the scale. That's the length of it. Then for the breadth now, which is 2 centimeters times 2 again. That's 4. 2 times 2. That's 4. Area is what? Length times breadth. That's 2 times 2 times 2 times 0.7, right? So that's why it's 8 times 0.7.
2 times what? 2 times breadth.
Length times breadth. That's 0.7 times 2
Yes.
times 2 times 2.
Okay.
2 times 2 times 2 times 0.7.
The base is one, that's not
Yes.
the base is one, and not two. Yes, it's two. It's two. I divided it to two.
Please listen. The width of this place, that's what we are using to multiply. It's length times breadth. This is the length here. This is the breadth here. What we measured in our book is 2. But because of the scale times 2, that's why it's 4. Then for the other side, we measure 0.7 times 2, that's 1.4. So before we write this one down, or if you like, you can just calculate what you have now, then write it here. So 8 times 0.7 is what? So what you are going to have here is 5.6. So for the next one, please measure what you have. Please, what do you have here in your next one?
Your length.
From this point to this point. So 1.5, anything else? 1.8. From the curve to the slope. 1.7, 1.8. Anything else? 1.8. So let's choose 1.8. So since you measure 1.8, that means it's what? That's 1.8 times 2, right? Then the breadth, 2 times 2. So that's the reason why I said 1.8
It's
times
still for
8.
8 now.
Because of the scale. Exactly.
It's still 8.
Yeah. 2.5 times 2.
Do it times 8 like that.
2.5 times
8.
8.
Direct.
Here, from here to here. Yes. From here to here, please, what do you have?
Into in.
Someone has gotten 3. Anything else? 2.8. 2.7, 2.8. 2.8. Okay. 2.8 times 8 is what? 2.8 times 8. 22.4. 22.4. So for this one, from here to here, please don't forget, from the curve to the slope is not from this horizontal line. 2.4. 2.4. Okay. 2.3, 2.4, 2.4. So 2.4 times 8 is what? 19.2. 19.2. So for the last one now, please. The last one. What we have here is not up to 2. What we have here is not up to 2. It's 1.25. So 1.25 times 2. Then times, what do you measure from here to here?
The last one.
We've done the last one. Please, we are on the last one.
No, 1. 0.9.
Okay, some people measured 1. I've seen 1 too in other cases. 1. So 1 times 2. So what do we have here now? 4 times 1.25. That should be 5, I mean. So the next thing is to get our W, which is gamma A. So, and our gamma from the question is 18 kilonewtons per meter cube. So you notice that by the time we multiply this together, it's still going to be kilonewton per meter. But since we are taking 1 meter in the third axis, So that's why this one is multiplied by this, multiplied by 1. So it will cancel out. So what you just have to do is to multiply what you have here by 18. Yeah. For those that have 5.6. 5.6 times 18.
100.8.
Then the next one.
Next one. 40.4 times 18. 259.2.
The next.
That'll be 360. 360. 43.4. 43.2.
The next thing now is to get our alpha. So for you to get our alpha, all you just have to do is to measure the angle between this line and this one that is crossing. No, we have two lines. We have one like this. Then we have another one like this, coming from here. So we have two lines. One here and the other one like this. If you look at it now, let's pick this one for example. We have this dotted line and we have this line coming from O, crossing it. So it's the angle between those two here. This is our alpha. This is also alpha, shall it's still the same thing. They are vertically opposite. Yes. So you can either measure it from here or you measure it from down here. The first one you should have should be negative. Then the second one should be positive. No, we have to. Whenever you have two angles like this one is what because they are vertically one times 2. No. It's multiplied by 2 or whatever we measure. Our scale is 1 to 200. So anything different from that? 7. That's -7. So please measure alpha 2. Okay, now we have it.
The measurement now is with reference to
so we are staying at the center, which is there's 13, there's 14, there's 15, and so we are at 14. No, write what you get though. Please write what you get. Don't write what's on the board. It's what is inside your book that you should write. We have alpha 4. 4 please. Different answers. 25, 26. Okay, 5.5. So actually, it's allowed. You can get decimal too, alpha 5. 32, 33, 34, 35. 40, okay. 40. So the last one. So now that we've gotten that, so normally you are supposed to go to cos alpha and sin alpha, but because of time, you can just go to W cos alpha, W sin alpha directly.
Because of time, during the test,
Okay, you are supposed to have cos alpha.
We are supposed to have cos alpha first and sin alpha, but because of time, you can go to W cos alpha, W sin alpha. Watch out, watch out. So can we start or we are still measuring? So 1 minute for that, please. Just 1 minute. Please listen, oh. Should we call it again?
So, decorum o continue máa sọ̀rọ̀ lọ wọ́n dákẹ́.
Because of the noise. So W cos alpha, that's what 100.8 cos minus 10. Someone should press that on calculator. So from here now, we are done with this diagram.
Yes.
2 cos 5.
Let's go direct.
258.21. So the next one, 360 cos 14. 360 cos 14. 349.3. 403.2 cos 25. 365.74. Then the last one, 90 cos 56. 50.32. So the next one, 100.8 sine minus 10. It should be negative.
Minus 17.5.
Minus 17.5. Then 259.2 sine 5.
22.59.
22.59. Then 360 sine 14. 87 directly.
0.09.
Okay, 0.1. 403.2 sine 25.
170.39.
170. Find the summation. So add everything we have here together. Add everything we have here together.
Yes.
So we are here to get our L. L is the length of the arc. So an L equals to. Is this right?
Yes.
Where theta is in radian.
Yes.
Although you can read it in English chart. Let's do radian. Our R is 19.8. Into bracket 72 divided by 180 pi. Which gives us what?
You said our theta is 75.
Yes. Oh, don't use 70. This is what you measured. What do you measure?
75. Like we 75.
75.
Use the one you made your.
Thank you. What was the one at the middle? Let's do 75. I think it's at the middle. This is the formula for finding L. We need L. Out of everything we have here now, in the formula, the only one we don't know is L. So that's why we have to find L. And L is R theta. But that theta is in radian. If you want to use degree, you can use theta over 362 pi r. That's for degrees. But if you want to use this formula, it's going to be the radius multiplied by the angle in radians. 25.9. So we've gotten our L, which is 25.9. Let's put it here. Okay. So I want to rub this one now, since you've written it. The angle you measure, theta. Yeah, the angle of rotation.
And length is 24.4.
Down to the final part.
Ọwọ́ náà ló fi parẹ́.
Our factor of safety is summation CL. We only have one CL, so this summation is not valid. So our C is 40, our L is 25.9. That's 40 bracket 25.9 plus tan 10. What our summation W cos alpha?
1387.25.
All over
559.35.
and our final answer is 2 point what? So we have 2.28. What was your 2.35? 2.35. So anything else? This what you have. This one that I wrote here. Let me quickly explain.
Another question.
Another
No.
question. Remember our slope is what? 1 to 2. 1 vertical, 2 horizontal. So what if our slope is 1 vertical to 1.5 horizontal?
That will be 3. Starting on the scale.
Yeah, it's going to be the same. It's going to be 15. But how do we get 15? So that's why I wrote this. Just to make it easy. Whatever scale, whatever slope you are given, you can just write it out. This one for vertical, then that 1.5 for horizontal. So our vertical height will be given. For this question now, the vertical height was 10 meters. It's the horizontal we are looking for. So we can call it x. So just cross multiply. X equals to 15. So you remember the one we did the other time was 1:2. Now let's do it like this and see whether we are going to get 20 or not. 1, 2 equals to 10 equals to x. Cross multiplying, x equals to 20.
So we are using 3 for that one ratio. For that one.
We are using 1.5. Yes.
As your scale.
No, not the scale.
Slope.
Okay.
It's for the slope. There's another way to it, yeah. The one the lecturer mentioned that day is finding the angle. And now measuring the angle.
Oh, a little better.
But this one, I think this one is straightforward.
But it's going to be 20 degrees. The slope line is going to be 20 degrees in this case.
See our own case.
In this case, they are 1.5
This
now.
particular case, you can calculate it now. You just do 1.5 this one. So the angle here is
Theta.
okay. 1.5 over 1.
It will be tan inverse of 1.5.
After 1.5 is what? Then you now subtract from 90. But then you don't know where you are going to stand on here to make the other arc. That's where the simple mathematics come into play. We already know that at the end of the day we are going to have a sector, right?
Mm-hmm.
Yes.
And from that sector we can have this chord.
Yes.
So all we just have to do is to find the length of the chord. The radius here is 19.8. The radius here is 19.8. And the angle we're given the question as 72. So all we just have to do is to find the length of this chord. The length of, not the length of the arc. The length of the arc is L. And we did that as r theta. But what we are looking for is the length of the chord. Let's call this place X. Now let's bring it out properly. Yes, we have an acceleration, thank you. So 19.8, 19.8. We are looking for X. This one now, you can decide to divide it into 2. Then now use Pythagoras theorem.
Yes.
Or you can use sine rule directly. We already know this place to be 72. this place and this place must be equal because it's an isosceles triangle. So 180 minus 72 divided by 2. That means this place is going to be 54 and this place is going to be 54. So from sine rule, we know that sine A over A equals to sine B over B equals to sine C over C. Now, we know two sides, we know all the angles, so it's easy for us, we have more than enough. So what we can just do is to say sine 72 divided by x must be equal to sine 54 divided by 19.8. So after cross multiplication, x will be 19.8 sine 72 divided by sine 54.
Yes.
This, can someone quickly find this? I think it should be 23 point something. Chord here now, we already know the length. All you just have to do is to stay on point B. Adjust your compass to 23.27. But don't forget, divide by 2. Exactly. 23.3 divided by 2 is what?
11.6 something.
11.6.
11.6.
So with your compass now, you stand on 11.63. You measure 11.63 with your compass. Then you now make the arc here. So this is where your chord is going to be. You have to draw that chord. So now, everything is now easy. All you just have to do is to go back to your 19.8, which is 9.9, right? Half of it. You now stand on this point. Okay? Cross this one. So you now join the two together. So by the time you measure this angle here, it's going to give you 72. It must give you 72. So if you do it well, it's going to give you 72. So yeah, you now draw this one. So that's just the only difference. And if you measure this one, it's going to give you something around that 1.25. And multiplying by 2 is going to give you that 2.5 that you gave us in question. Something around that. Right. So that's just how it is.
Okay, so now the right way, we can't really use it to